Hello again. Today I will be discussing a topic within the analogy between geometry and physics. That topic is the concept of net charges and angles and the relationship between them.
A problem associated with understanding quantum chromodynamics, the theory of the strong nuclear force, and its three charges red, green, and blue, is the units we use to measure it. Color was first described by Nambu Han and Greenberg in the 1960s as a note. Electric charge is measured typically in coulombs, which can be positive or negative. But with three charges, there is no longer a single duality of positive and negative quantities. So we realize that there are three net charges associated with the red, green, and blue associated with the three dualities within that system. We should remember that Charles-François de Cisternet-Dufay, when initially defining the two electric charges in the 1730s, called them vitreous and resinous, with positive and negative only being added later, since most objects were considered neutral, with an equal amount of vitreous and resinous fluids making positive and negative fitting. For three-dimensional substances like baryons, there are three net charges. In geometry, there is only one kind of angle in a two-dimensional space, but with a three-dimensional basis of minimum three vectors, there are three different angles in this minimum basis, which make up a single solid angle. The three angles are like the three net color charges: quantity of red minus quantity of green, quantity of red minus quantity of blue, and quantity of green minus quantity of blue. For three-dimensional substances, there is a preferred ordering just as with angles, clockwise versus counterclockwise angle, with more vitreous than resinous being considered positive, and the other way around being considered negative. So we must have a preferred ordering for the three-dimensional substances as well. We know that there is a quantity known as total charge, which is the sum of positive or vitreous and negative or resinous quantities, and a similar quantity for color charges. This is similar to how in geometry we have a product of length and width, and a product of length, width, and height to measure the quantities known as area or volume, respectively. The four basic operations are represented here: addition, total charge; subtraction, net charge; multiplication, area, volume, or end volume; and division, angle, the quotient of the length of a portion of a circle, and the radius of that circle. This demonstrates how the net charge is the material equivalent of the spatial concept of angle.